Hi, I'm Stanley Wei, one of the two project leads for Bruin Underwater Robotics, or BUR for short. We are a technical project under the American Society of Mechanical Engineers at UCLA, and this is our third year competing in Robosub, as well as doing the sort of autonomous robotics more generally. So coming into this year, we had two main goals, the first being to improve our existing systems, and the second being to explore new design challenges as a club. Unfortunately, with regards to that second goal, new design challenges, those efforts were not completed in time for this year's competition, so they won't be competing. But for the first goal, we made a number of improvements to our existing bot and systems that we're excited to share with you. So yeah, please enjoy.
Hi, I'm Molly, one of the chassis leads. Chassis spent most of the year designing a smaller, more maneuverable bot that we plan on competing in the future while also improving the larger competition bot. One thing that we spent time developing this year was a double piston seal for our bot's flange. We chose to make our eBay more robust and further prevent water seeping in. Another change that we made to the big bot is converting our current vertical thruster mounts to aluminum. The reason we decided to make this change was to strengthen the mount since we are currently using 3D printed mounts. The small bot is currently being manufactured to prepare it for future competitions. Our main goals were to reduce the overall size of the bot as much as possible and optimize the eBay.
Hi, I'm Peter, another DevOps lead. This is our claw. We use a pneumatic and a 4-bar linkage to actuate our claw open and close more efficiently. We made a new mounting solution, rotated 90 degrees directly onto the chassis, and we worked on TPU adaptive claws that bend around what they're making up.
I'm Luis, I'm one of the DevOps leads this year, and DevOps handles all of our pneumatic systems in our bot through our pneumatics box, which contains all of our solenoid valves. Our pneumatic systems go to our dropper, our torpedo launcher, and our arm. So our torpedoes handles the launching of torpedoes, which I have one here. This year we focused a lot on torpedo optimization, so we made a custom test rig, which has the same exact system as on our robot, same solenoid, same pneumatic actuator, and we would just launch torpedoes and compare our simulations to see if we have the optimal shape.
Hello, I'm Lucas, our hardware lead for this year. Our hardware team primarily focuses on designing all the electrical circuitry and systems that run our robot. These designs power everything from our computers to our pneumatics, and they spin our thrusters. And we teach all of our members electronics from the ground up, from basic circuits all the way up to PCB design and manufacturing, to give them a solid foundation for electrical design. This year, our primary focus was updating and refining some of the electronics on our current bot, enhancing our safety and performance capabilities. Primarily, this meant a full redesign of our battery management system to include onboard voltage measurement and an externally magnetically actuated e-switch.
Hi, Stanley again. This year we had two main goals for software. The first goal was to improve documentation and lower the learning curve. We started up a new internal wiki to help improve knowledge retention, and furthermore, we incorporated Docker virtualization for easier setup and better reproducibility. The second goal was to improve aspects of our existing subsystems. We replaced our previous VAD controllers with cascaded position velocity controllers in order to improve controllability and autonomous operation, and verified their performance via experimental testing.
Hi, I'm Julian, one of the software leads this year. For our vision systems, we focused on improving our synthetic training data to make it better resemble real competition images. We upgraded our Unity environment with reverse projection caustics and increased water clarity. We also used Fourier transform-based domain adaptation techniques to better align the frequency domain characteristics of our synthetic data with those of real-life images. By training on data more resembling real competition conditions, we make our model more accurate and robust.